Hi and welcome. In this video I will try to demonstrate how you can true your wheels if you have wheels on your bicycle that are wobbly or out of true and you have some problems and you wish to touch them up and fix them. I have already made a series of videos about bicycle wheel building where I have explained everything in detail, and I will try to make that video, the first one in the series, pop up in your top right corner. So if you need to build wheels from scratch, you can look at that. Also, I have made a series of articles where I've explained everything in great detail. For me, it's easier to learn from articles, and I rely on videos when I need something demonstrated. So I will make the list of those articles also now, if I don't forget, when I upload this, pop up in your top right corner, so you can look at that on my website, bike.bikegremlin.com. And now for this video, I want to first stress that building bicycle wheels as well as truing them is no special science, no mystical skill. It's a fairly simple, straightforward process. It does take patience, and this video will not be short. Unfortunately, I want to cover all the high points to make a complete but easy to follow tutorial, so it will be a bit longer, but if you have enough patience to watch this video, you probably have enough patience to do a good job with your bicycle wheels. So it's nothing to be afraid of, but you need just to take it slow, one step at a time. I will make chapters in this video that will be visible in the timeline so that you can skip to the parts of interest if you watch it first and then rewind to see about certain points and problems that you come across to make it more easier to navigate. And this first long tedious part will be called the introduction. Of course, I'm that inventive. And now let us start with the basics. Now when you see that you have some problems with your bicycle wheels, I especially notice this after a crash, when people bring a bicycle after they've had a fall or a crash, and they think, oh, my wheel is bent or my frame is bent, what's going on? Very often it happens that only the wheel needs to be put properly into the dropouts, especially with wheels that don't have those true axles. There it doesn't move very easily, but with other wheels, that's the first thing. And here we have some quick release wheels, and I'll show how that is done the easiest way, especially for bicycles that have vertical dropouts, which means that the wheel goes from the bottom straight up. They are not horizontal. Some bicycles have horizontal rear wheel dropouts, and there you have to make it like a jockey a bit, but here we'll just show this. I'm releasing the quick release lever. Okay, it's released, and I want to make sure that bicycle is on the ground and I'm pressing on top, and I want to make sure that it has some wiggle room so that it's nicely seated. And I can feel when I misplace it to one side that it's gotten out of the that side's dropout, and when I pull it, when I let it go, it should come back. The same goes for the other side. So I want to make sure that it's seated all the way, exert some pressure, and then lock it up. Okay, this is too tight. Okay, now I've got it locked up properly, and now I can recheck and see if everything is okay. Very often this helps, not always, but very often it does. Now I'll put it on the stand. If this does not help, the next thing that often is the case is that your tire has some sort of a problem. Very often when you see a wheel wobble left from right here, I think this one does. You can see it in the camera, probably, that it moves from left to right. Okay? Sometimes that is the result of the tire being a bit deformed or not seated properly. You can double check by placing something against the rim, and I will show now the simplest way to do it with a zip tie. That is also the way to improvise a truing stand out of your bicycle if you don't have a truing stand. If you have rim brakes, that also works very well. but if you do not, then you can work it with a zip tie. I will not tighten it too tightly to not damage the paint, but here I can cut it to size. If this were not like an angled, I would probably cut it shorter and move it here, but I can also make it work like this. This works like a decent gauge. I'm not sure if you can see in the camera, but you want at maximum 1 millimeter of space between the gauge and the wheel, and then you can see if the rim is out of true or not. If you notice that the rim is true, but only the tire causes any wobbling, then you are good to go. It's not a problem, most probably not a problem that requires wheel truing. I'm mentioning this because I see it very often with poor quality tires or tires that are damaged. I will also note another problem. If a tire's side walls get damaged or cut, or the wires that hold them together are a bit damaged, sometimes not even clearly noticeably, they might have a small bulge in the sidewall, and sometimes it's not nearly as easily noticeable. In that case, the tire may cause the rim to be out of true, because it is not pulling on the rim with equal strength in all sections, and that can result in a rim pointing when you make some sort of a gauge. Rim obviously moves out of true, but when you replace that tire with the new one, even when you just remove the tire, you can see that the wheel is true. So that is a way to, in a long and tedious way, stress that. To be sure, you should remove the tire and then check what the situation is with the rim when you are truing it. And you do not need always a truing stand. You can make your bicycle work like a truing stand with no problems. It's more practical, and we will be showing this on a truing stand, but it's not really necessary. When it comes to the necessary tools for wheel building, you basically need a good quality spoke key. I will just now show what a good quality spoke key looks like and what a poor quality spoke key looks like. Here we have a good quality spoke key that has a small slot in the middle, and it holds the spoke from all four sides. Sorry, the nipple. And I will show how it looks like when I put it on a nipple. I place it over the nipple, slide it on, and here you can see that it is engaged on all sides. On the other hand, if we look at this design, this spoke key will hold the nipple only from two sides. Let's see. This is the dimension we need, but it holds it only from two sides practically. This side at the bottom does nothing, and you are very likely to round off a nipple and damage it when you are tightening or loosening very tight spokes with a spoke key like this. So I don't consider them to be of any good for bicycle nipples. That's basically the most important tool that you need, that is essential. And the next tool that you need is this paper tape that is sticky, because you need to mark some things, and if you get interrupted you need to place where you have stopped. If you don't start with this one, you might regret it and remember this story. Okay. Apart from that, it is of course very good if you have a truing stand, if you have a dishing gauge, we'll explain that later, and if you have a tension meter, we'll also explain that later. Also, a good pair of gloves of not cotton but leather. A good pair of leather gloves is also important, as we will show and explain later. And you might need some like feeler gauges. These are metric ones in millimeters, to check the tolerances when you're building it. We'll explain that later also. However, you can get away with using just some calipers and an old credit card or some sheets of paper to improvise a filler gauge, to check when you have succeeded. And also, let me show here. Instead of a tension meter, you can get away with your hand feel and guitar plug. It's far from perfect. It's for me a lot more difficult and slower, but it can work, and I will also show that. And so now where do we begin? I want to first, after explaining the tools, explain what we are trying to achieve. Of course, we want to true the wheel, but what does that mean? I will now explain that because I think it is important to understand, and many people miss that because it's too obvious, like not seeing the forest from the trees. So when we talk about wheels, the thing that gets most often neglected is the wheels dish. What that means is whether the wheel is placed in the center line of your frame along its longitudinal axis, if that is the right word. So we want the rim to be center-lined. And if we take a closer look at this rear wheel, we can see that here we have a huge amount of space for the cassette, and here we have a lot less space, which means that this rim is not in the middle between these two hub flanges. It is closer to the right-hand side hub flange, but in order to be in the center line of the bicycle between the dropouts. And I often see, especially with rear wheels, that they are moved a bit, the rim is moved a bit to the left, so it's staying closer to the center line of the distance between the flanges instead of being center line between the dropouts. That causes poor bicycle handling, and sometimes when people have problems with their bicycle handling and they think that something is wrong with their frame, the first thing I do is to check for the wheel, or check the wheel dish, and of course I give the wheel a spin to see if it's too wobbly. But that is often a cause of a problem. With the disc brakes, it's not as clearly visible. With rim brakes, it's easier to notice if that problem occurs. So it's important to have the proper dish. That's what it is called. Next thing that is important is called lateral trueness. What that means is that the wheel is true in terms of not moving to the left or to the right, not wobbling. So if this wheel wobbles left and right, it's not laterally true. And the third important thing when it comes to truing wheels is called radial trueness. That effectively means that the rim does not move up and down as it spins, but it stays at one level. That is called to make it radially true. If there is a spot during the wheel's rotation where the rim is further away from the center of the hub, so it looks like it's got a small bulge, that is called the high spot. While if we have a place where the rim is closer to the center of the hub, so it's like it has a sort of a dent, that is called the low spot. We don't want any of those. And also it is important to know when to stop. When we are building wheels, you can waste hours without getting anything better that really works in practice. What we want to achieve are the acceptable tolerances, and for the dish, that is within 0.5 millimeter towards the left or towards the right, away from the perfect center. That is considered acceptable. Frames often have that not nearly as precisely aligned, so the wheel moving a bit to the left or to the right for up to 0.5 millimeters is considered very good, or lower, of course, that's perfect. As far as the lateral trueness goes, so the wobbling left and right, there we can go for up to 0.25 millimeters to the left or to the right, so a total of 0.5 millimeter of total movement. When it comes to the radial trueness, there the acceptable limit is up to 0.5 millimeter up or down. If you get it within those measures, you will not have any problems when you roll with that wheel, and it will not be measurably worse than a wheel that is perfectly true. So that is what we are trying to achieve. And another important thing that many people don't get, even some wheel builders, at least from what I could tell, is the importance of uniform spoke tension. I'm trying to stress this because if you want a wheel to stay true, you need to have it with a uniform spoke tension and with an optimal spoke tension. What are those two things? When we talk about the optimal spoke tension, that means that the spokes should not be too loose, too slack. So, because if they are too slack, the wheel will be of less strength. I made a video explaining the spoked wheel strength. If I don't forget, I'll make it pop up in your top right corner now. So the spokes that are tighter make for a stronger wheel. They will not make it stiffer. That's a common misconception. They will not make it less comfortable, but they will make it stronger. However, if you overdo with spoke tension, you might damage the interface between the nipple and the rim. That is first weak point. And you might also deform the whole rim. Rim is the weakest link when we talk about wheel strength, if we are talking about properly built wheel with cross lacing. So you don't want to overdo it, but you don't want the spokes to be under tensioned. That is the first criteria to take into account. And the second one is that you don't want to have spokes with different tensions. For rear wheels that have the dish closer to the right hand side flange in order to make the rim in the center line, the right hand side spokes need to have a lot higher tension, sometimes almost twice the tension of the left hand side spokes in order to keep the rim centered, because the left hand side spokes have a better angle for bracing, and that's explained in the video that I had mentioned, so I won't go into details there. So it's normal for spokes on one side to have greater tension than the spokes on the other side. But if you compare all the spokes on one side among each other, you want their tensions to be as close to equal as possible. It's not always possible to make it perfectly equal, because the rims and the spokes and the hubs and everything else is not perfect, but you want those to be within plus minus 10%. So no more than 20% difference between the tightest and the loosest spoke. It would be best if you can get that up to 10%. So optimal spoke tension and even spoke tensions are both important. Why? Because I already explained the optimal tension, and as far as the equal tension goes, if you have one spoke that is a lot tighter than the other spokes, it will carry a bit more load, it will be more stressed, while the other spokes will be able to get a bit loose and work themselves even looser, or break at the elbow of all the flexing and material fatigue. So in order to make all the spokes work together as much as possible, you need to have a uniform spoke tension. It's easy to build a wheel that is perfectly true, like super perfectly true, but without the equal spoke tension. That is something I see very often, and those wheels are not very durable and long lasting. On the other hand, if you make a wheel that is not 100% perfect, just within those tolerances that I have mentioned, it will last a lot longer. So as long as you have optimal and uniform spoke tension, that is important to achieve. I will also now, this is important, and I'm mentioning it because I often see people don't understand it and disregard it and have problems. So I'm sorry if it's a bit long, but I'm trying to compress a lot of information. It's simple to follow, and I think it's easier, for me at least, to follow instructions if I understand why I'm doing it. So this whole part of the video is for that reason mainly. When we are truing a wheel, what we are basically doing is tightening or loosening spokes by turning the nipples. We can show it here. If I put this spoke key here, in order to tighten the spoke, I will turn it in this direction, like this. That's counterintuitive, and people often, when you see me building wheels, ask me why I'm unscrewing nipples when I'm tightening spokes. So I'll show it in the bottom. It's even more noticeable. So here, in order to tighten this spoke, I would not be turning the spoke key in this direction. That would be loosening it. But I would be turning it in this direction. Because what I am doing is, this is how the spoke looks like here. What I want to do is to screw the spoke, the nipple in order to pull the spoke tighter. And when I see only this protruding, it looks as if I am screwing it out when I'm actually tightening it. And when I do what with normal screws is tightening, so turning in this direction, I am basically loosening the nipple. So I want also to stress that. It's a bit counterintuitive. And you need to pay attention to that when you're building the wheels. You might even draw some sort of a point on your spoke key to remember what side to push and how to turn it. It can help. And when I am tightening a spoke, there are spokes coming from one side of the hub flange and from the opposite side. This is the right hand side and this is the left hand side. If I tighten a right hand side spoke, the rim will move closer to the right hand side, so I'll be pulling it this way, and I will also very slightly pull it closer to the center line. On the other hand, if I tighten the left hand side spoke, then I will be pulling the rim to the left hand side and also a bit closer to the center line. In the opposite direction, if I loosen a spoke on the right hand side, the rim will be moved to the left because the other spokes have the same tension, and when this one that counters them gets loosened, the rim will move in that direction and a bit to the outside to make it less close to the center of the hub. And the same thing happens for loosening the left hand side spoke. Then the rim will move to the right hand side. So I'm achieving practically similar thing to if I loosen left spoke. It does similar thing to like I do when I tighten a right hand side spoke, only in that case the rim will move a bit outwards instead of inwards towards the center line. But in terms of lateral trueness we do that, and when we only touch one spoke, the movement in terms of closer or away from the center line is not that much, especially on a highly tensioned wheel when you have almost already finished wheel, or you need to true a wheel that's come out of true. But if you tighten two spokes, especially two adjacent ones, then you will be able to see measurably the rim be pulled inwards. And that is what we use in order to get that radial trueness. We take one spoke from the right side and from the left side and tighten them to make it closer or loosen them to make it further away. It's also important to mention that for rear wheels that have that right hand side flange closer to the center of the rim, so rim is closer to the right hand side flange and right hand side spokes have a lot higher tension. When we want to move the rim just further inwards, we need to tighten the right hand side spoke more than the left hand side. So I would move the right hand side by half a turn and the left hand side spoke or nipple for quarter of a turn. Why? Because the right hand side spokes have a more awkward bracing angle and they will be not as efficient. So if I need to increase their tension a lot more to make the same movement of the rim, and if I only want to move the rim up or down, I need to tighten both spokes without moving the rim left or right, and that is achieved by not doing an equal amount of tightening. The same thing goes for loosening. I would loosen this one for quarter of a turn and the left one for half a turn in order to make the rim just move a bit outwards but not move anywhere to the left or right. Of course I would double check and touch up, but that's the basic principle. Another thing when we talk about the radial trueness is called feathering. And that is if I see a big bump here, like the rim is too far out and it spreads along this section, for example, in order to fix that, I will start from the middle to make a more drastic change. For example, tightening the right hand side spoke by say half a turn and the half a turn and the left hand side by quarter of a turn, and then I will take the two pairs of spokes that are further away and not do as much of a change. So I would use quarter of a turn for the right hand side spokes and just 1/8 of a turn for the left hand side spokes. So I'm feathering out the adjustment because the center of the bump is here, if that is the case. That is also an important thing to do. I would not try to get it fixed by just working with the spokes that are right on the top. The same thing goes for any low points or where the rim is too close to the center of the hub, so we have like a sort of a dent. In that case, I would do the opposite, only with unscrewing the nipples, but the same principle, feathering it out. Now I think I've covered all the basics to explain what we are trying to achieve, what we are trying to do, and now we will get on with truing this wheel or any wheel. The first thing that you should do is to remove the cassette and the disc if you have those, just in case, to get a clearer view and to make it easier for you to work. I have already made videos about removing cassettes and discs. You can look them up on my channel, so I won't be wasting time with that. I will take another rim to show what is important next. Here we have a bicycle wheel, and the first thing that I would suggest doing is removing the tire, and then using either your frame or a truing stand, see whether the wheel is true. If it is not true, then what I would do is inspect the rim for any dents or big hits. If it is damaged, it's usually the best idea to replace it. I think I have a video on how to replace a rim with a new one, but if the rim is damaged severely, it's generally not very easy to make it become true. And if you're trying to true a rim that is dent, you will not be able to achieve that with a uniform spoke tension, so you will have problems with breaking spokes or loosening. So it's a wasted time. It's not a very smart job to do. So check if the rim has any sort of problems. Next thing that will be more visible in, okay, let's go on. Here it's visible here. You want to make sure that all the spokes are okay. They usually crack near the nipple, near the elbow or near the nipple. So you want to make sure that they are looking okay without any cracks, and you also want to make sure if they have any cuts or big kinks or anything. It happens on the right hand side spokes if a chain drops off the cassette and gets between the cassette and the spokes, that it will damage the spokes, like halfway cutting them through or similar, burning them severely. So in that case, it's probably a good idea to replace the spokes. If they're looking okay, or if they only have some kinks, that can be straightened out. You loosen them, straighten the kink, and then re-tighten them and true the wheel. Another thing to pay attention to, we'll show it on this wheel. Here is the nipple to the rim interface. You should inspect the whole wheel around the whole circumference to make sure that there are no cracks or problems. Because if those occur, that means that the nipple is getting pulled out of the rim and the spoke is losing tension, and as you tighten it and true it, it will keep on cracking and coming off, and so it's wasted time. It's not a well done job. Okay, so that is the first thing to check. When you've checked that, you should just do one more thing. I almost forgot to mention one thing, and thanks to the magic of video editing, I could put this in the video. You should also check the hub flanges. There are sometimes cracks on hub flanges, which effectively makes the spokes looser, but as you keep tightening them, it will make those cracks greater and maybe completely break off a part of a hub's flange. So also check that, clean it, and inspect. If you see that your wheel is out of true before you start truing, make sure there's no damage on those as well. Check it from both the outside and the inside, which is not visible now easily, but that is the idea. Also check for any play in the bearings. If the bearings are loose, your wheel will be wobbling to the side, laterally untrue, but it's because of the bearings. So also make sure there's no play in the bearings. These ones are very loose. They either need tightening and lubricating. These are pitted and worn, but when they're like this rocking, it will make the rim move left and right and not stay in place as you're trying to true it, so make your job more difficult. And if the hub is toast, then it's futile truing the wheel and building it with that hub. So that's also another thing to consider. So I think I've covered all the high points now. Let's move on. Get the leather gloves to not hurt your tendons or your skin, and tighten 2 pairs of spokes. I will show how to do it on this rim. I have to do it from this side. I always do it from this side. I start at the valve, and when we work with wheels, valve is always where we start and where we end. So it's like a orientation, and make sure to always turn it in the same direction so you know where you stopped. So I'll be turning it forwards and start at the valve. I'm looking for pairs of parallel spokes on each side. You have like 2 spokes that are parallel, so not these 2, but I want 2 that are parallel from one side. These 2 instead of these 2. Okay, so those, and on the adjacent ones also parallel, so not these 2, but these 2. I will take them, so pairs of spokes, and squeeze them very strongly with as much as I can. If the spokes are not damaged, or if nothing is in trouble, you will not be able to break them. You needn't worry about that. And if there is a problem, you want to notice it right away. So I would do this first before I start with truing a wheel that is already built. This is also called stress relieving, and you do this when the job is finished, and it's the only proper technique for stress relieving. Okay, I've done it, no spokes have broken, and now I can start truing the wheel. I will remove it from the bicycle and put it on the truing stand, and here I've already changed it to the smallest sprocket to more easily remove it. And let's see. Okay, here it is, the wheel, and for brevity, do as I say, don't do as I do. I will try without removing the cassette or the disc brake, but if you intend on to loosen many spokes or work on them, then you should first remove those, because if the rim is loose, if the wheel is not tight, you will not be able to easily remove them afterwards. Now what we should do is to remove the tire, of course, and I have a video about replacing tires, so there is no need to show that in detail. We will probably speed this up or cut it out of the video. Okay, so we have removed the tire and we have a rim, and generally we don't have to remove the rim tape if we are just truing the wheel and not replacing any spokes or nipples, so it can stay in place. But what we can do is lubricate the interface between each spoke and nipple to make our job easier. That's better done when the wheel is not under tension, but I think it will not do us harm. It can only help us if we do it even now as it is. So that's what we will do. Let's put it in a truing stand to work easier, to make my life easier, hopefully. Okay. The first thing I will do is mark the valve. It sounds like a stupid thing, but when you're working it even with a wheel that is completely finished, it's better to have that more obviously noticeable, the start and end position. So I will put some of the tape on the valve. Here it is marked with white color on this rim, but nonetheless I will put some tape on it. And you can miss it, so you don't know if you've made a half a turn or 1.5 turn. It's important to make sure where it is and to have it noted. And now we will start turning in this direction, starting from the valve, to put a drop of oil onto the spoke so that it flows inside the nipple through the threads as much as possible. So I'm placing it like here, letting it slide. And I also want a drop here to slide inside and lubricate the interface between the nipple and the rim so that the nipple can turn more freely. Here is what that looks like. You can see the end of the nipple as it leans against the rim. It's got a wider top section, and I want some oil flowing in between that interface if at all possible. Okay, so I started at the valve and moving on. And I want to do this around the whole rim, and then I will give it a good spin to make sure that it all flows inside by the centrifugal force as much as possible. It does make a bit of a mess, definitely, and you do have more work then to clean the rim of all the oil, and you might want to give it a wash, and that's all good when the wheel is done, when it's trued. You should also make sure that the hub is okay, that there is no play. That is important. If you have play in your hub, that could also cause the rim to go out of true and the wheel to wobble, even though it's not about spokes and you need to fix your bearings. And that is a topic for a separate video. I've made the videos about servicing cup and cone hubs and setting preload and so on. I'll not be bothering you with that. And now let's see first what our wheel looks like. We can try it from, I can turn it like this, it's easier for the camera, I think. Okay, so let's get these closer. And here we will be able to see radial trueness will be shown by the rim moving further and closer to this point. Let's exaggerate it. So this will be our radial trueness, and lateral trueness will be moving further and back from this one. So technically only one truing gauge is enough, even though for me it's easier to have two. So let's see what this looks like. Okay, it's wobbling all around, and it's difficult to tell the radial trueness until you get it laterally true. It's very imprecise. So that is the first thing that we do. But before that, I will check the wheel's dish. You can do that on your frame to see if it's in the center between your frame's forks or the rear. Those angular tubes or chainstays or whatever, if they are symmetrical. But here we will use the gauge. Okay, and let's give it a test. And this is a very simple tool. I align the gauge with one dropout. And this is what I mean by the dropouts. I didn't mention that. So I'm aligning with this face that goes on the inside of the frame. So that is one side, and this is the other side. That's what I want to have. The same distance, frame should be at the same distance from one to the other, unless you have a frame that is asymmetrical, but that is a topic for a separate video. There we have to do some compensating. Okay, so let's see here. Okay, I'm aligning this with one dropout. Okay, and let's see the other side. If it can be caught on the camera. Here, I hope you can see this dropout is further out, which means, as we are measuring here, you can see it, it's not aligned. It should be like this at the face of it. Sorry, trying to catch it on camera. It should be pointed at the face of the dropout, like this, but it is not what we are measuring is like this. Okay, so that means that the rim is moved further to the right hand side. So that is not perfect. It's not a huge margin, but roughly over 1 millimeter. This thing exaggerates the error because it doubles the error. We measure from one side and then to the other side, so they add up. So if I have like 2 millimeters here, that means that the rim is off by 1 millimeter. However, I want to fix that. This is not acceptable. But what I also want to do before I start anything is to check for the spoke tension uniformness and for the spoke tension total. Is it optimal? If you don't have a tension meter, you can just feel it with your hands, starting from the valve, taking parallel spokes and twisting them to see if there are some that are noticeably a lot more loose, like this one. See how this one moves compared to the other ones. So if some are too loose or too tight, obviously noticeably. And here tension is all over the place, and when that is the case, it might be a good idea to start from scratch. Remove the rim tape, loosen all the nipples and start all over. But we'll double check this. What you can also do, if you don't have you should test some well-built wheels to get a sense of how tight enough spokes should feel like. So for example, let me take a tension meter. For example, let's start at the valve. These two spokes look like they are okay. And let's find some that are loose on this side. No loose spokes on the right hand side. Okay, these ones are a bit loose. Okay, these ones feel loose and these feel okay. You can double check that if you don't have a tension meter using a guitar plug. You can hear the difference in pitch of the sound. The looser spokes do have a bit less high of a pitch. For me, it's a lot easier, of course, to use a tension meter, and that's what I will do. And another thing to note, here, let's give it a test. The spokes that are crossing each other on this wheel, they will affect the resonant frequency. So you might want to be holding the spokes that are crossed. So if I'm testing this one, I want to take my hand on this one to prevent it from affecting the resonating frequency. And now as I move further and hear the next one, and so on. And the way this one is used, let's zero it in. Let's zero it in. Okay, I'm holding it pressed and zeroing it in. And now I want to place this along the spoke near the end and let it go and see where the needle is at. Okay, let's move on. Okay, around 120, just under 120. This one is very loose. This one is very loose. I will mark it near the nipple to know that it is loose. Let's move on. This one is also quite loose. I've marked it a tad higher because it's not as loose as this one. This one is a bit too tight compared to the other ones I've tested. So I'll mark it a bit higher up to know that this one might be too tight. This one is way too tight, definitely. Okay, let's move on. This one is okay. Now let's do the same thing for the left hand side. There I expect generally lower tensions on average, not around 120 kilogram force, but around 60 probably. So let's start the first one, about 80. This one is very loose, under 60 kilogram force. Okay, we'll note that one as being very loose, unacceptably loose. Let's go on. This one is too tight, way too tight. If I look at this wheel, in this case the situation is pretty bad, and we have the spoke tension going all over the place, and it might be a good candidate to remove the rim tape, loosen all the nipples, and then use this tool. This is a screwdriver with a 3mm tip that I've ground down, and that enables me to screw in the spokes, the nipples equally until it gets pushed out by the spokes, so that I start with a wheel that is relatively evenly tightened, has relatively evenly tightened spokes, and then go on truing it. Generally, for situations like this, here you can see, let's pick a good candidate. Let's see what this rim, how this rim behaves. It's very erratic, going all over the place. It's very difficult to know which side is moving out of place. And here you can see that in this section it moves wildly towards this side. Okay, let's look at this section. Here we can see the rim moving wildly to the right, and we have two spokes that I've marked to be under tensioned, and this spoke that I've marked to be too tight. That is what might be causing the rim to be moving that much out. But here on the other side we have another loose spoke. So while this right one might be pulling it a bit to the side, this one is too loose, so it makes it go to the right more easily. It's not compensating. So that is what could be causing the rim to go out of whack in this place. But I also have another beauty here with one spoke that is too tight next to another spoke that is too loose. So it's very hectic. With this rim, the situation is very hectic. When you have a fewer of these problems and mismatches, you can easily find the reasons why a rim is going out of true in one place or closer to the center of the rim or further out. But when it's all around here, going from almost 0 kilogram force to 160 kilogram force relatively randomly, it's difficult to figure it out. And when you tighten spokes on one end, it affects the movement of the rim all around, just most noticeably at that spot. So again, when the situation is like this, I would most probably just start from scratch. Let's try to loosen it a bit. And another phenomena. Let's try to capture it on camera. See this spoke's tightness. It's around this mark, okay? And now what happens as I loosen adjacent spoke that is too tight? Can you see? It's losing tension. Why? Because this spoke is pulling the rim to the opposite side, making this spoke effectively elongated because it needs to go further to reach. And as I'm loosening it, the rim is moving away from the left hand side, from this side, and that makes this spoke effectively less elongated to reach the nipple, so it's losing tension. And that is why a small amount of adjustment does affect adjacent spokes and even around the whole rim, so you need to take it gradually, one smaller adjustment at a time. Otherwise you will have it all messed up and you won't be able to get it fixed. Okay, this is now around 110 kilogram force. It's okay. Now let's see about this spoke. Again, as I said, in situations like this, in my opinion, it's best to start from scratch, because it's very difficult to get a uniform spoke tension and figure out what causes problems and also it could be that the rim is bent or has some sort of a big hit, and the only way to know that for true is to loosen the spokes and see if the rim is having some very big problems, so that at least I know that I cannot get a uniform spoke tension. So this video was not a very successful one, unfortunately, and we would have to remove the rim tape and start from scratch. I don't know how to make a wheel that it has this many problems true with uniform spoke tension without starting over. If there are some minor problems like one or two spokes being loose or similar, it's okay, but in this case it's a very strange situation. This is beyond my level of knowledge and experience, and what works for me in situations like this is to remove the rim tape, loosen all the spokes, then screw them in using this. I'll demonstrate it now. Using a tool like this, so as I'm screwing it in, the spoke will push the tool out. I'll hold this with my finger, not with too much force, just to prevent it from twisting from friction alone. I want this to stop when it gets out, so that every nipple is exactly the same amount of threads engagement, and then I start equally tensioning all the nipples by 2 turns or then 1 turn and so on, and measuring the tension, measuring the lateral trueness, radial trueness and gauge, and getting the wheel to the proper state, as I've explained in those videos explaining wheel truing. Now I will just take the time to explain the gauges and the acceptable tolerances. With this rim it would be very difficult. Okay, it's in place, and now let's see for lateral trueness. Unless the rim has some dents, it's enough to measure from one side. I want to make it start slightly scratching on one side, and then I want to find the place where it is the furthest away from the rim. For that I cannot see now without blocking the camera, but let's say that this is the place where it's furthest away from the rim, and I want to measure if that is less than 0.25 millimeters. So here we have 0.25 millimeters feeler gauge, and let's say this is the spot, and I put this between. If it cannot fit, that means that the distance is smaller. You can improvise this by using calipers and finding some thin materials that you measure to be of that thickness, and then use them, like several leaves of paper put together or something, or a credit card or so. So that is for the lateral trueness, to see if it is within acceptable tolerances, and if that's okay, I also want to make sure that radial trueness is okay. So what I do here is put it like this, and here I have some places where it just scratches, but it doesn't really push against the gauge, and that's good. And I want to measure the distance when the rim is furthest away from it. Let's say that is this spot, let's say, and see if it is less than 0.5 millimeters, preferably less even than that. If that is okay, we're good to go with it. That's a good, well-built wheel. But I also wish to check out the dish, and also for that I would be using a tool like this. And let's see what the dish is like. Okay, this is from this side, and let's check out the other side. Yeah, this one looks very, very nice. Okay, so this is a very old rim, very old wheel that I used on my daily commuter for years in all sorts of terrains, and it didn't see any touch-ups after it was built. And I did try to get a uniform spoke tension and to get it to an optimal spoke tension, and also the rim is quite strong, so it nicely distributes any loads to several spokes, and that also makes it play nicely on very bumpy roads and harsh rides. So it's a fairly well built wheel. It's not perfect, it's never perfect, but it's good enough, and the most important thing for me is that it stays like that. It doesn't get any worse over time. So that for me means it's a good wheel. For that wheel that I showed in this video, unfortunately, I wanted to demonstrate the touch up and truing, but it was not possible with that wheel. And this doesn't need it. As far as I can tell, it doesn't need any touching. So more talking than real action. Sorry. Another thing that just to note, let me see. I'm not sure if you can see. This is the place where this rim was connected. Sorry, it's too dirty. And on the other side the rim tape blocks it. On that spot you might see the rim be a bit, just a tad wider on both sides, usually symmetrically, or a tad narrower, depending on the rim's build quality. And also you might see it have a low spot, like being closer to the middle, to the center of the hub, in spite of spoke tensions being all good or equal. Or you might see it having a high spot, so being a bit outwards further, in spite of all the spokes having uniform good tension. Do not try to get that part perfect. If spoke tension is uniform and if the wheel is within the given tolerances, you might have a sort of a bump, like, or a kink here at the place where the rim is welded, and in order to compensate for that you would have to have a non-uniform spoke tension. So you would have to tighten, for example, if I have a high spot on this section, I would need to have both of these spokes a lot tighter from both sides, and they will be not then in uniform tension from relative to the other spokes on their same side. So that will make for a weaker rim, because it's usually that place where rim is not really perfectly round, more pronounced than the other spot, and it usually takes a lot of tension overcompensation to fix that. The same problems happens if you have a rim that is bent or dented or something. Again, there too you will face the same problem. So that's another thing to note. I'm not sure if are we under 1 hour. No. Sorry for a too long video. I hope it helps you. We have some ASMR value, and we are competing with the damn dripping faucet video for the most boring video on the internet. So please like, share, subscribe, and I hope this video helps you at least a bit, and I'll see you some other time. Cheers.